Hello, this is Peter Heinrich. I appreciate you for joining me. I'm a developer evangelist with the Amazon App Store. And I should just start by saying that yes, I know that that is kind of a goofy title. It's kind of strange. I get pretty funny looks from people actually when I tell them that. But from the reaction, I gather that most people don't hear developer evangelist as a job title very often. It's actually a great job. I really enjoy it because it's part engineering, it's part marketing, and it's part customer service. So essentially my job is to help developers be successful with Amazon, whether that means using our hardware or software or both. And it turns out that while just about everyone is at least somewhat familiar with our hardware, like Fire Tablet or Fire TV or especially the Amazon Echo, which these days is making quite a splash, a lot of developers don't know anything about the software libraries and platform support that we offer to help them speed their time to market and simplify their development. So this presentation isn't actually designed to be a crash course on every App Store library or program. Instead, I'm going to show how some of the APIs we offer can be used alongside Unity, which is one of the most popular, if not the most popular, third-party development platforms for mobile app and game creation. We will see some actual code today, but in the end, I think you'll find that in keeping with the general ease of use and accessibility of Unity itself, the technical details of getting things to actually work are really pretty manageable. So laying out our agenda for today, I'll briefly describe some of the APIs that we make available through the Amazon App Store, and then I'll talk even more briefly about what it takes to get access to those APIs. And then I'll walk through two services in particular that you may want to incorporate into your Unity app. Before we get started though, let me get some basic webinar housekeeping out of the way. The first thing you should know is how to deal with software problems during the webinar. And if you ever have any issues like glitchy video or glitchy audio, unusual slowdowns, etc., just hit this little button. Let's see if I can get it to highlight. There we go. And it will refresh everything. It will usually make everything better pretty much right away. Next, please ask questions. Feel free to do that. I'll answer them at the end. But if I don't get to your question during the webinar, if I'm out of time or it's a duplicate or something like that, then please feel free to follow up with me afterward. My Twitter handle is peter.games, and you can also reach out to me directly at my email, which is simply heinrich@amazon.com. So let's dive in. The Amazon App Store has a number of ways in which we try to help improve your app's customer experience, its user retention, monetization, and in general, revenue generating opportunities. And our guiding principle is pretty straightforward. Amazon's founder, Jeff Bezos, laid it out in just 7 words. And they apply to all areas of our business: retail, web services, content on demand, and digital. And this principle applies regardless of how we define, quote unquote, the customer in each of those areas. So for App Store, our customers include users, obviously, for whom we're a means to obtain content they want, but they also include developers on the other side of that equation, the ones trying to get their work into the hands of the public. And that means that App Store has 2 very different kinds of constituencies, each of which requires us to work backwards in a slightly different way. There's a unified vision across both, though. We want to delight customers by connecting them with the content and experiences that they want, or we think they might want, and this obviously serves the content creators and the consumers. From the consumer's perspective, the most direct manifestation of this is the App Store itself, which comes pre-installed on all Amazon devices and can be side-loaded on any Android device. It's an app marketplace that also offers features and benefits unique to Amazon, like Amazon Coins, a virtual currency, and Amazon Underground, a program that allows customers to install and use premium and freemium apps at literally no cost forever. On the developer side, there are many services that we provide to simplify and lighten the burden of development, making it easy to add functionality and features that you would otherwise have to code yourself. And this is in addition to programs like Amazon Coins, which I just mentioned, which happens to be totally transparent to developers, by the way. That is, you don't have to do anything. No changes to your code are required at all, and you still benefit from enhanced customer engagement. And then Amazon Underground is another example that serves the developer as well, providing an alternative monetization model that can be superior to premium or freemium in the right circumstances. So for several of these APIs, we provide direct Unity support in the form of downloadable plugins. So using them is as simple as including any other third-party library in your Unity app. We have Unity plugins for in-app purchasing, or IAP, mobile ads, Game Circle, which includes achievements and leaderboards and game data syncing with WhisperSync for games, and Amazon FLING for enhanced multi-screen experiences. To download these Unity plugins, and before you can use the services from within your mobile app or game, you need to register as an Amazon developer. This is completely free, and if you're already an Amazon customer, you're actually halfway there, since mostly we just need your name, address, and email. So, kick things off by going to developer.amazon.com. We call this our developer portal, and it's the one-stop clearinghouse of everything you need to develop for Amazon devices or use App Store services. You'll find links to documentation and sample code. You'll also find payment and analytics dashboards and app publishing tools, videos, resources like marketing and promotion guides, all these things designed to help make your mobile app or game successful on Amazon. And then once there, you can sign in with your existing Amazon account or create a new one to link with your development. If this is a new account, we'll ask you for some basic profile information like your name, address, and email. And then afterwards, we'll ask you to agree to our app distribution and services agreement, which is pretty standard fare. None of the legalese will be unfamiliar if you've ever published a mobile app on iTunes or Google Play. I'm sure the terms are similar, so no real surprises there. Okay. If you will be generating revenue through your app, then once you provide us with the banking info that will allow us to pay you, we'll also ask you to complete a couple of tax identity questions. We do this in order to fulfill some requirements that we have to make fulfill some requirements that are imposed on us by the government. But we will collect some basic information about your bank first. This is actually the trickiest part because looking up your bank info you may not be used to doing that, but we need that info in order to be able to pay you if you generate revenue within your app. So filling out the basic government questionnaires isn't particularly difficult, but we do recognize that, it may be inconvenient. So we have to do this in order to fill out, or in order to satisfy government requirements. But we try to make the process as painless as possible, understanding, your pain. Believe me, we feel it too. Practically speaking, though, filling out neither one is particularly difficult, and seldom will this step add more than just a few minutes to the whole process. So once it's done, you'll never have to do it again. You only have to complete these forms once, no matter how many apps you publish using this account. And that's it, as far as account signup goes. Now you have full access to our entire developer portal, including all the documentation and downloads. And we have a bunch of SDK files and code samples there as well, so you can use this handy-dandy bit.ly link, bit.ly/AppStore SDK, to access them directly. And then once you're on the page, just scroll down to find the links to the files you want. And you'll notice that there are iOS resources as well as the ones you would obviously expect to find for iOS and Android, and that's because some of our services, like Amazon mobile ads or log in with Amazon or Amazon Cloud Drive can actually be used with iOS apps too. So Amazon App Store services aren't limited to the Android platform. Okay, so let's take a look at a couple of these services and what it takes to use them within a Unity project. We'll start with Amazon mobile ads, since they support a very popular, very common monetization model across just about every category and genre of mobile app that there is. So, first the basics. The Amazon Mobile Ads API is exactly what you'd expect. It's an in-app display advertising solution that allows you to monetize mobile apps and games across platforms. That includes on phones and tablets, both Android, iOS, and in addition Fire OS, which is based on Android. And it offers great revenue potential because you get paid on ad impressions instead of the more typical ad clicks. And the ads themselves are highly relevant and mobile optimized, either for Amazon itself or for a select group of high-quality brands. Now, the program right now is available in several geographic regions, which include the UK, United Kingdom, the US, Germany, France, Spain, Italy, and Japan. Now, you as a developer can be located anywhere. You're obviously not limited to those geographies. Those are just the regions where Amazon mobile ads are served. So if you have customers in those areas, the Amazon Mobile Ad Network is a great option. The Mobile Ads API supports a few basic ad types, starting with static banners. These are essentially HTML web views that typically open in an in-app browser or native browser or Android intent. You have rich media expandable banners, which are HTML web views that expand in-app with rich interactive content. Got static interstitials, which are full-page ads that usually appear at a transition point in the app. So, for example, moving between game levels. You have the modeless interstitial, which is a full-screen ad that can be embedded inside a container view, provided that the container is large enough. And that's frequently useful for things like image carousels, where you may have an ad interleaved in between other content. And then finally, you have rich media interstitials, which combine many of these features at once and allow you to add rich interactivity and enable click-to-play video. So now that we know a little bit more about the Mobile Ads API, how do we go about incorporating it into our Unity app? Well, the first step is to add the correct plugin to your Unity project. And in your Unity development environment, just open the Project tab, right-click on the Assets folder to bring up the context menu, and then we're going to select Import Package and choose Custom Package. In the File System dialog that pops up after that, navigate to the folder where you downloaded and extracted the SDK. And we're looking for the file with the .unity package extension. Select the Amazon Mobile Ads .unity package file, click Open. And once you do, Unity will show the list of files to be imported and allow you to check for conflicts with files that are already in your project. Now, if a conflict does exist, it's up to you to save any local changes somewhere outside the project and then merge them back in manually, but we've gone to some effort to minimize the likelihood of conflict, so hopefully you won't run into this. And then once complete, your project folder may look something like this. You'll see the Amazon Mobile Ads plugin listed under Assets/Plugin/Amazon, right alongside the Android and iOS folders that contain the native code to integrate with the SDK on those platforms. Now, with some services, and the Amazon Mobile Ad Network falls into this category, there is going to be an application key that the service uses to enable access and tie usage back to your specific app. When you publish apps on the Amazon App Store, just as on other app stores, they will appear on your management console, allowing you to add product listing assets like screenshots and videos, add a description, etc. You'll also be able to review the application keys associated with your app. So, for instance, to see the key that enables the mobile ad service in your app, you'll go to the app management page and then click through the mobile ads link. Now, your app won't automatically have access to the Amazon Mobile Ad Network. The first time you click through this link, you'll basically be saying, yes, I want to use mobile ads in my app. Please turn on access. So after that, just click Submit to save the setting. Then the service knows that it can serve ads in your app, and it will generate a unique ID for you to use to identify it as a valid ad client. So in my example here, the mobile ad network has created this unique identifier that associates my Android app with mobile ads and identifies it as a valid client. And it will expect me to supply this value when I make calls to the service from within the app. Note that there will be a separate, different ID generated for the iOS version of my app if I choose to make one, and I do that here as well. The service can then differentiate between the same app running on different platforms. And here we get to see our first real code. This is a Unity script to initialize our connection to the Amazon Mobile Ad Network using the SDK we imported from the plugin. Now, where you put this code is really up to you, whether you have a dedicated game object or you roll this into a special initialization module. Wherever it ends up, note that I created a public string containing my mobile ad application key, and actually I created two, one for Android and a separate one for iOS. Then down below, you can see how I added a preprocessor directive to choose the correct string based on the platform where my app is running. Now, once I have the key, I can pass it to the SDK through the object that I created, and that holds the API entry points for the service. Now, since we're good programmers and we have a healthy paranoia when it comes to testing, we're going to enable testing and logging for our calls to the Mobile Ads API. And this boils down to retrieving the interface object again, the Amazon Mobile Ads implementation instance, then setting the current state of its testing and logging members. This is especially important if you yourself are located outside any of the supported countries. Remember, those are the UK, US, Germany, France, Spain, Italy, and Japan. And it's important because calling the API not in test mode from other geographies will never actually display anything. Now on Android, before we can actually create a test ad, we'll also need to make sure our Android manifest includes a few key features. Number one, we need to make sure it requests the right permissions to enable access to the service. Namely, it needs to request internet, access network state, and access Wi-Fi state. And number two, we need to add the com.amazon.device.ads.add-activity. Now, in the interest of time, I'm not going to go into detail about the corresponding steps on iOS, but you can find all the information you need to do that on our developer portal. Now that we've turned on debugging and logging and made sure our app has the correct permissions via the manifest file, and also explicitly declared the mobile ads activity, we can try creating and displaying a test ad. And again, it's up to you where you want to put this code and how it gets called, since it's really just a test. Maybe you could attach it to a UI element, like a button that you press whenever you want an ad to appear. Regardless, the goal of this method is to create and display a floating ad that's docked to the top of the screen and centered. In this case, we'll use a helper class provided by the SDK called placement that allows us to specify parameters related to the ad size and positioning. And next, we'll call the mobile ad service to create an ad object having the correct placement. Finally, we'll tell the service that we actually want it to return us something from its ad inventory and then display it. Remember, if you're not in a supported geography and haven't enabled testing, this won't work. So be sure to turn on testing if you're outside of one of the supported countries. But since we are in a supported geography, or at least for this demonstration I am, and we turned on testing, it does work, and here's what we get. We get a simple banner ad, docked and centered at the top of the screen, which in this case is in landscape mode. And the SDK will automatically take care of rotating the ad based on the orientation of your device. So you can see it's pretty straightforward to create an ad object and set some parameters on how it should be displayed, then initiate a call to retrieve ad content and throw it up on the screen. And you can see, for test purposes, it's easy to put the SDK into testing mode, letting you retrieve all kinds of ads, even if you're not physically located in a region where they're actually supported. Now, the Mobile Ads SDK exposes quite a bit more functionality and configuration, and that's all supported by the Unity plugin as well. So you can register callbacks, for example. You can have your game objects be notified when ad content actually loads. So you can, for example, pause game music while an ad is displayed, or take some other action. Or maybe you want to handle errors in a particular way. So if the ad doesn't load, you do something else. Use a mitigation service to rotate through other ad providers, for example. You can achieve this type of control through callbacks, which you define as functions in your C# script somewhere, as I've done here. And then you register them with the mobile ads wrapper that you instantiated at startup. And that's the pattern that you apply pretty much any time you want to incorporate an Amazon API into your Unity app. It boils down to 4 basic steps, not all of which are necessary every time. But first, you obtain a handle to the implementation object defined in the SDK that acts as your interface to the service. Next, prepare any parameters that you may need to pass into the API for it to operate on, or that will otherwise modify its behavior. Some APIs take no parameters, so this step is sometimes completely unnecessary. Third, in cases where a result won't be returned immediately, define a callback function to process it when it does become available. And finally, go ahead and call the API member method on the implementation object, passing in the parameters that you initialized. This is the basic outline for calling any Amazon API if there's a Unity plugin for the corresponding service. So that's Mobile Ads. It's a remote service. It runs on our services in the servers in the cloud, and it can return content to your app in response to a request. Let's look at another example, one that's effectively local. The Amazon FLING SDK. It's a cross-platform toolkit that enables mobile developers to build rich, multi-screen experiences with Amazon Fire TV. Now, while it does allow sending video, audio, and images over a network to Fire TV and Fire TV Stick, it actually doesn't depend on the cloud. So we don't have a service running somewhere that does all the work. The SDK allows you to, quote-unquote, fling video content to Fire TV devices, and the code to do iOS, Android, Fire OS, and it allows you to build these rich multi-screen experiences for Fire TV devices. You can send media from your mobile app, regardless of platform, to be rendered on a Fire TV or Fire TV Stick. And the SDK allows your mobile app and destination device to communicate back and forth in both directions, so it's possible to create engaging second screen experiences. Working with the FLING SDK from Unity is substantially the same as we saw for Mobile Ads, although in this case, there's no application key that you need to keep track of and pass in when the SDK is initialized. So I guess in that regard, it's actually easier to use. But just as before, though, somewhere initialization must take place, and the SDK will give you back an implementation object that you can then use to execute API calls. Now, it happens that FLING is actually heavily asynchronous compared to Mobile Ads, but that's not a problem for us because we saw how to create callback functions already, and there's really nothing to it. Just like Mobile Ads, the FLING SDK has some special APIs to set specific event handlers, and we just need to define the function somewhere and pass in the names and then make sure they're accessible. So the FLING SDK requires us to flesh out just a few handlers, methods it uses to asynchronously tell us about potential target devices, where we can send media, control the volume, pause, play, etc. We can tell the SDK to start looking for targets, and then it will alert us whenever it discovers one. And we can then take the opportunity to update a list of potential targets for the user. Similarly, if a device gets turned off or moves out of range, we can be notified that it's no longer a valid target. Now, the Unity plugin that we make available actually supports both sides of the FLING SDK. That is, you can use it to create an app that accepts flung content, that is a target app, or you can create a controller app, one that can initiate playback, choose content, etc. Like mobile ads, there are a few modifications you have to make to your Android manifest file to enable FLING functionality. Again, basically this comes down to adding the correct networking permissions. If you're deploying on Fire OS, it turns out there's no need to link with the WhisperPlay jar file since it's built in. Instead, you just add that uses library line there to the application section. On iOS, it's slightly more involved, so I won't go down that rat hole. Instead, let me just direct your attention to the bit.ly link at the bottom of the screen, because it leads to an in-depth explanation of everything related to deployment of FLING-enabled apps on iOS, Android, and Fire OS. So, what do we take away from this? Well, I hope, above all, that I've made it clear just how little effort is actually involved in integrating Amazon APIs in your Unity apps. The basic pattern isn't complicated, yet it opens up several useful and cross-platform services for easy inclusion in your apps. All you need to do is register as an Amazon developer for free, peruse the features and functionality of the services that we make available, and then use the Unity plugins on our developer portal to connect your app to the service you need and publish on our store. And that's it. Quick and dirty. If you want to review any part of this presentation, it's actually being recorded right now, so if you missed something or you'd like to look at it again, it'll be available on demand after this. Now, we'll take a moment to look over the chat, and I will be right back to answer any questions you may have. Feel free to stay on for the Q&A coming up. Otherwise, thanks for joining me. I really appreciate your time, and I hope this was helpful. Thanks.